Alright, this is Mr. Gillum, and today we're going to be looking at some linear graphs again, and we're going to put some real life situations um, with those linear graphs. These problems are similar to ones you're going to see on your study ion assignment tomorrow, so make sure you take really good notes today so you have a good example of how to solve some of these different problems. Before we look at this multiple choice question here, let's read the question carefully. It says, a restaurant has tables with 3 legs. So when I think that, okay, I think, all right, we got 3 legs on this table. Okay, which of the following shows the number of legs compared to the number of tables? I need to stress independent and dependent variables a little more, I think. I think that hopefully everybody can agree that the number of legs depends on the number of tables there are. Okay, now in this problem it specifically says the number of tables is the independent variable x, independent, and it says specifically that the number of legs is y, the dependent variable. But I hope that it makes sense in your head that the number of legs depends on how many tables there are, the number of tables. So before I actually look at these graphs, I'm actually going to think of this as an XYT chart. Okay, and I just need to use some, I don't want to say common sense, but some intuitiveness here. So if I have, and remember x represents the number of tables, if I have 1 table, then I know that we would have 3 legs. If I had 2 tables, then I would have 6 legs. And so as you can see, depending on what x is going to depend on what y is. 3 tables would be 9, 4 tables would be 12. And so I don't want you to just approach this problem and just try to do it in your head and give it your best guess. I want you to think of it kind of as a table of values here. Now this table of values should line up or match one of these graphs. So let's take a look here. In the first graph, it looks like, remember these are ordered pairs. It looks like if we go over 1 up 3, that's where the first point should be. And so I'm going to say the first graph is no good. 1 table, 3 legs should be up here. So I'm going to say he's out. Let's go down 1. Over 1, up 3, it should be there a little below that. Or 2, 6 should be above that. Look more like that. So I'm going to say that graph is not a good linear representation. The third, let's look at the bottom right hand corner so we can eliminate him too. If I move over 1 table and up 3 legs, that would be representative of that coordinate. And 2, 6, and again, so it looks more like this. So I'm going to say that graph's no good. So hopefully this other graph here, if I move over 1 table, I know I have 3 legs. If I have 2 tables, I have 6 legs. 3 tables, I would have 9 legs. Okay, so I feel like this one would be the best representation. And again, make sure you take good notes on this, because if you're just trying to do this one in your head, it might be kind of difficult to interpret the graph without the t-chart. So I like to think of these things in t-charts first, and then I try to match the graph with the t-chart. Okay? And again, I should stress independent and dependent variables. The number of legs depends on the number of tables. So in this case, it tells you that which axis is which, but I hope that we can start deciding that for ourselves here in the future. This question says that Maria charges $5 per hour for babysitting. She wants to calculate the total amount of money she will earn this week. What variable is needed to calculate her earnings? Okay, so before we look at this, the multiple choices here, I just want to analyze the question a little bit. If I were to think of this as a t-chart, I would probably compare the number of hours worked compared to the money made. And the reason Mr. Gillum would do that is because the amount of money you make depends on how much or how many hours you work. Okay, the amount of money you make depends on the hours worked. So I would set my chart up kind of like that. Now this specific example doesn't really require a t-chart, but we need to emphasize a little more about the independent and dependent variables. Remember, x is the independent and y is the dependent. So the amount of money made depends on how many hours you work. So in this case, though, it says she wants to calculate the total amount of money she will earn this week. What variables needed to calculate her earnings? In this case, it says. So we're thinking, what is it dependent on? Her earnings. What are they dependent on? I would say the number of hours worked would be the independent variable. So in this case, it says D, the number of days per week she babysits. Okay, well, that's not a bad choice, but really she's getting paid per hour, not per day. So I'm going to say A is probably not a good choice. It says K, the number of kids she babysits. Again, she's not getting paid per kid, she's getting paid per hour, so I'm going to say that's probably not a good choice. I think it depends on the number of hours worked. And C says the amount she charges per hour. Well, no, that's not a variable. We already know she gets paid $5 per hour, so a variable about how much she charges isn't really a good choice either. And then H, the number of hours she babysits. That's the one that I think. It only makes sense to me that the amount of money she makes depends on how many hours she works. So the independent variable in this case would be the number of hours she babysits. That'll change how much money she makes. Okay. At Hamburger Heaven, they use 2 buns for every hamburger. The following shows how the number of buns, Y, changes as the number of hamburgers, X, changes. So again, and I know it doesn't use the word independent and dependent, but I hope that it makes sense that the number of buns, so if this is a chicken patty or whatever it is, a Hamburger Heaven, it depends, the number of buns depends on how many, there's your burgers, how many patties there are. So when I think about it, I think of, okay, the number of patties, the number of buns depends on the number of patties. So if there's two patties, there would have to be 4 buns. If there's 3 patties, there'd have to be 6 buns. If there's 4 patties, it'd be 8 buns. So what I've done here is I've made a T-chart again, and I'm all about the T-charts. So where X represents the patties, the independent variable is patties, and the Y, the dependent variable, is buns. Okay, because the number of buns depends on how many patties you have. So here we go. In this case, it gives us an equation here and a graph, and we came up with a T-chart. I like these problems as T-charts better, really. We have a linear relationship here. Okay, we can see the pattern going 1, 2, 3, 4. We can see the graph is in a nice straight line. And in fact, we already know how to make a T-chart given the graph. So hopefully this T-chart that I made matches the graph. Let's find out. I see the point 1, 2. I see the point 2, 4. I see the point 3, 6, 4, 8. Okay, so I think that my T-chart does match the graph well. What we learned about the equations is, or we learned how to fill out our T-chart, but we also have been practicing checking our work and using substitution. So let's just look at these and see which one is going to work. And we'll just start with A. If these are coordinates, X and Y, then I know that I'm going to take out the Y, put in the 2. I'm going to take out the X, I'm going to put in the 1. Does 2 equal 2? Yes. Okay, so far we're all right. Let's try the next one, 2, 4. And as long as all of these solutions work and we're convinced that the pattern follows the pattern, then we're good to go. Let's see here. Does 6 equal 2 times 3? Oh, well, yes, it does. 6 does equal 6. Okay, I'm starting to think that this is going to be the one that we want. Let's try 3, 6 and see if that one makes sense. Does 6 equal 2 times 3? Yes, it does. Oops, I already did that one, didn't I? I skipped one. So 6 does equal 6. We already knew that, Mr. Gillum. I skipped 4. 4 equals 2 times 2. Okay. All right, so I'm getting the impression that A is going to be our best answer. Let's take a look, though. We just kind of got lucky there. Let's take a look at B. When I use B, I see that 2 equals 1 plus 2. And 2 equals 3. Is that true? No, so B can't be the answer. Let's double check with C as well, and I'm just using this first point here. 2 times 2 equals 1. The x number is 1, the y number is 2. And again, 4 equals 1, that doesn't make sense. So C is out. And then, of course, 2 plus 2 equals 1. No, doesn't make sense either. So we got lucky on part A. All of our coordinates fit in there and make sense. But on B, C, and D, that's not the case. So I like to think of these as a T-chart. So if you're having a hard time with your problems on Steady Island, I suggest you make a T-chart to start and see if that helps. In this case, long one, it says Aiden has $65 in his bank account. His brother Michael also has a bank account. They want to calculate the amount of money in both accounts combined. What variable is needed to calculate their combined total? So before I look at the choices, Mr. Gillum thinks, okay, we have Aiden and we have Michael, and we want to know how much they have altogether. So when I think about this problem, I think about addition, because however much Aiden has plus however much Michael has will be how much their combined total is. Well, we know how much Aiden has, 65. So what we need to know is how much Michael has to find the combined total. So let's look at our choices here. A, M, the amount of money in Michael's bank account. Okay, that's the one I like. D, the difference between the amounts in Aiden and Michael's account. Now, if I'm trying to find how much they have altogether, I don't think that subtraction or difference is going to help us. I'm going to say that one's probably not a good choice. A, the amount of money in Aiden's bank account. Well, that is one of the things we need to know, but lucky for us, if we're careful readers, we'll know that we already had that information. So I don't need that information. Or L, the amount of money in Michael's account last month. Well, you know, this question really is specific to what it is right now in both bank accounts. So the amount that he had last month might not match the amount that he has this month, so I'm going to say that one's out as well. Okay, so I'm going to say in this case, M, the amount of money in Michael's bank account would be very important in solving this equation. So, or this expression in this case. So that's it for today. Some examples from your study island. If you're having a hard time with that, the first thing I would start by doing would be to make a T-chart and see what we can figure out from there. So that's it for today.